Hey there, students. So you should have already attempted this exercise, and then I'd love to chat through it now with you. So, cool. We've got a Ferris wheel over here, and you can see a picture of what they look like. Great. It's 60 meters in diameter. Let me start putting stuff on here. 60 meters in diameter says that like from, well, I'll go across here. From here across to there, 60 meters. Okay, good. And it rotates once every 4 minutes. So maybe I'll say like this point here goes all the way around every 4 minutes. And the center axis of the Ferris wheel is 40 meters off the ground. So from here to the ground is 40 meters. And I guess maybe I should put meters on my 60. Great. So using the axes below, sketch a graph to show how the height of a passenger will vary with time. Assume the wheel starts rotating when the passenger is at the bottom. So one of the things I think about is that if the whole way across is 60, it means the radius here is 30, which tells me if I put a radius here, that's 30. The rest of this space is 10 meters. So when a person gets on, I would picture the person getting on at the bottom. That's the way Ferris wheels have worked when I've ridden a Ferris wheel. So at the bottom, we're 10 meters off the ground. That's when the person is getting on the Ferris wheel. Cool. It takes 4 minutes to go all the way around. So I just think like this is 1 minute, 1 minute, 1 minute, and then 1 minute to get back there. So it means at 1 minute, we're like over on this side, which is we started at 10, we've gone up, now we're at 10 plus 30 is 40. So 1 minute, we're at 40. And then second minute, we're up here. So at 2 minutes, we're at 10 plus 60 is 70. And then at 3 minutes, I'm coming back down. So now I'm back here. And at 4 minutes, we're back to where we started. At 5 minutes, we're going around a second time. And this starts to get easy. Great. So then we need a way to connect these dots in a reasonable way. When I picture this type of motion, just thinking about that, it's like curvy here. So it's not linear. It's like we're at this bottom piece for longer, and then we accelerate upwards, and that's the way your graph should look. And then here, we accelerate quickly, and then it slows down when we get near the top of the circle. So it's gonna look something like this. Good, and then coming down the other side, we get that same shape. Those of you that have had me before, I hope you remember this activity, and I hope it's easier than it was before. So something like that, and if it keeps going around, good, that's what we're looking at. So now we need a mathematical motion for this formula, and we've got a plus b cosine ct. Well, I wouldn't mind however you went about this, so maybe I'm just gonna go to, for example, Desmos, and if I get my graphing calculator, I could just say y equals a plus b times cosine of c t, I'll put x. So if we do that, it gives us sliders for these. And then I could just think, okay, in our case, we wanted to, we want 40 to be the center of the Ferris wheel. And I'm just thinking about matching these things up. I could just play with this. So, just thinking about the different things here, maybe I could just see, okay, now I get an idea what A does, and I have an idea what B does, okay, an idea what C does. Oh, C seems crazy. So let's play with the other things first. So if I play with, let's say B first, because I know I want that radius to be 30. So if I go out to here and I look at this, it's hard to tell. Maybe if I set A to 0, it'll be easier to tell what that radius is. So that radius is going from 0 to 10. So I can see when B is 10, we have a radius that goes from 0 to 10, which means I need to set B to 30. And now I see the radius of that Ferris wheel being 30. Great. Next, I want to shift this thing up. And when I move this, I can see that's what A does. So if I want to shift it up, like there I'm at 40, but I want the top of our curve, where was it? Here. I want the top of our curve to be at 70. So I need to like shift up a bunch more. Let's just see, what about if A is 70? Well, now I've shifted up too high. I want the top to be at 70, and I see the middle is at 70 when I do that. So now I'll set the middle to 40, and now the top is at 70, the bottom is at 10. This matches up with what we want. So good, cool. The last thing is we need to make this C match, and I can't like stretch out my x-axis, so it's harder to see what the C does. But you notice the middle of our Ferris wheel is in the right place, the top and bottom of our Ferris wheel is in the right place, and we've gained some idea of what happens. A, we can see shift things up and down, and what the A value is the middle of our circle. B, then was it made the Ferris wheel bigger, and B equals 30, that was the radius of our Ferris wheel, so good. And then C, we can see it messes with time, like that makes it go faster, this makes it go slower, and so we need some measure of time to be able to mess around with C. So we want at 2 seconds to be at the top, and at 4 seconds to be back to the bottom. So at 4 seconds we're at the bottom, at 8 seconds we're at the bottom, at 12 seconds we're at the bottom. Let's go to Desmos and try to figure this out. Because 4 seconds is tiny. We want to be back like from the bottom to the bottom. And, oh, and we need to start at the bottom. Means, it means, how do I describe this? Okay, here we're starting at the top. So if I want to flip that upside down, I would think here I want to multiply by a negative. So let me go ahead and put that negative in, and you see now we're starting at the bottom, which is great. After 4 seconds, we want to be back to the bottom. After 8 seconds, 12 seconds, 16 seconds, and 20 seconds, we're back to the bottom. So I'm going to think 4, 8, 12, 16, 20. We want to be at the bottom 5 times between 0 and 20. And then I'm going to mess with C and try to get us to go. So, well, now I'm at the bottom 1, 2, 3 times. I want to be on the 5th time when we hit 20. So 1, 2, 3, 4, 5. The 5th time it's hitting there, maybe instead of 1.6, I'll go to 1.5 is not quite right. 1.6 is also not quite right, but it's very close to that. If you were just trying to mess around with values like this, I'm happy with what you're thinking. This C value, honestly, we don't need to talk about super in depth, but I would like you to have the idea that A is adding, so it just moved up and down. That's what A did. B was multiplying, so it changed the radius of the circle. And then C messes with time, which makes sense. C is multiplying our x value in our situation was time. So if we multiply that x value, then we're messing with time. I'll just use these values for now, but I'd like to note that this 1.6 is close to perfect. It's not exactly perfect, because I would want to be 1, 2, 3, 4, the 5th time exactly at 20. And it looks like it's not quite at 20. Yeah, 25 pi over 4 is going to be close to 20, but not exactly on. So anyway, I'll use these values for now. So it was 40, negative 31.6. So for this equation down here, I would have h equals 40, negative 30 times cosine. And if you use something like 1.6t, I'm great with that for now. If you think you have the exact value for this C value, then let's chat, because you might, and I'd be interested in your strategies. But for now, if you were just using a graphing calculator or graphing utility and puzzling through it, that's totally good with me. So good. Now we have an idea about what these things do. And specifically, we've seen, I could type this. Specifically, we've seen A moves the center of the circle, which makes sense because A is like adding on up here. I don't have a good place to put this, whatever. B changes the radius of the circle, and I'll just say C messes with time because it multiplies X. And that's as much as you need to know for right now. If those things feel okay, then you're ready to go on and try the matching here. So best of luck. Let me know if you want to talk about things, and I'd love to chat.